Hello everyone, so welcome to the new video, and we had those parts assembled in the previous video, but there was some adjustment that I do, like the total height or length of the bolt is now reduced so that it match the height of these two. And also we have a small, and we can have actually a small gap here. It's about 3 millimeter, and so that's what according to the design that I've received. So those are the new things, and also the location of these bolts or little bit down compared to it was somewhere here previously. All right, so the next thing we're gonna do is we also need to have this area bolted, and for that we need to have those bolts. All right, so what I'm gonna do is I'm gonna need this, and I don't want two, just probably one. Let's look in this direction, and instead of 35, let's say it's 150 so that I can clearly see my bolt. Okay, so that's the bolt for these two, and basically I need one more. So I'm gonna choose this. Yeah, anyways, let me just choose. I don't need two in this direction, but one, and I can choose the direction should be Z, but flip the other direction, and that's it. Let's just first of all rotate those two bolts. So what I'm gonna do is I'm gonna transfer those from here. I don't know why I can't see the why this line is not matching here. I don't know, but we will deal with that later. But first of all, let me see. It might be that way because of the curve. So what I'm gonna do is just, let's say, translate this point all the way to this location, and okay, and again I can translate, nope, rotate this. So the starting point of the rotation could be this, and let's say I'm gonna rotate it to this. Let's see if, oh no, it won't rotate in the same. Okay, let 90 and to 70 is how about 180? Nope. So it should not be these 2 points. Done this and choose that point. Okay, now we are good. And okay, last thing I'm gonna do is to translate this pole to this point. Done. So what I can do is to select that point, this one here, and this point should go to the exterior, which is this point. This is the exterior most point. Before pressing OK, you can verify that the bolt is aligned accurately. Yeah, I'm having kind of feeling that the bolt is aligned from this. Okay, we did not consider this. Let's see. Okay, we have to consider that, which means we have to increase the thickness of the bolt now. Why? Because the difference in the thickness of these two plates. Yep, that makes sense. And also translate this point, could be any of those points. This, so now it's this one, so it should go to the, oh, let me see, let me just do it in the same way, so that if we could extend the length of the bolt, it should be symmetric. We don't need to change that again and again and again. This thing, and okay, and done. Is there any gap here? Oh no. Okay, yeah, I can see a gap. So what I can do is to tools, query, distance. I'd like to know the distance between these 2 points, which is 25 mm. So that should be exact same distance from this point to this point. But in other way, if I would like to know whether this point is aligned horizontally with this point, so what I can do, just choose this point and node, choose this and turn. So the x-axis is 152.75, and the same I can do for this one and done. So yeah, these are perfectly aligned along the x-axis, which means these two are attached to each other. But it won't be the case here, if you can see. So it 127.75. Obviously, when you subtract 25, it will give you 127. And this will not be 127. It's okay, so 0.5. The difference is 0.5. We need to move this part 0.5 in x direction. So to do that, let me just quickly have this point as a reference and turn. So now I have the coordinates of this point, and I already know if I move in this direction, the x will be increasing, which means positive. The x should be 127.7. So I'll copy those. Why do I need to copy those? Because I want to keep my y-axis and z-axis exactly the same, but I want to move it in the x direction. So just now translate, choose this, done, and this I can paste the original, but instead of 25 I can have now 127.75, and there you go. Let me see, seems to be okay now, or no, 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 no. 127.75. No, let me see, what was this point again? This 10. So the x is 127.75, and what's the x of this point? So now select the starting point. Oh, I didn't select the starting point, my bad, in the previous one. So I need to choose first the starting point, and then I can vary it to 75, and now it should be exactly aligned. It's actually the difference in the height here. Let me see. Okay, so what I can do, just it's let me press OK for that. So probably it will be difficult to see from this angle or any of the, even you can, when you rotate this, you're probably gonna see, okay, there's a gap. No, there is not actually. It's just this thing that is showing it's a gap, but now it's not. They're perfectly attached to each other. Alright, so that thing works, but there is another thing we might need to change is we move this plate in this direction, so that means this bolt might need to be changed, because I'm guessing it's not exactly at the same location. Let me see, I'll check this first. So what I can do just is move this point to here, turn, and then again I can rotate the same thing to be exactly the same. So this is the point I need to choose and should be exactly at this location. And okay, I can also do the same for the other board, but either way is okay. I can either check it along the z-axis. So in this case, the center line of these two bolts should be the same, which means the z-axis of this point, which is negative 62, and of this point, which is negative 138. So it's not exactly the same. Oh, sorry, my bad. The x-axis, not the z-axis, because they are aligned across the x-axis in the same direction. So that should be 76 in both cases, but the first one is 76, the second is 76.5. Why? Because we moved this plate 0.5, so obviously it makes sense. So now I can translate this to any other location. Let's say here to here. Select the endpoint. This is my endpoint, and okay, again translate this. Done. I need to have this point. Sometimes difficult to get. Now I got this point, and top up here. Boom. There you go. Now all my bolts are lined. Okay. Alright, so the next thing is the model is now assembled. So now we can come back to the material properties. We can define materials. So the first is the steel, let's say, general density. I'm using the SI unit, so it will be the 7800 kg per meter cube, and then mechanical elasticity, the modulus is 200 to 9, which is 200 gigapascal. Poisson ratio is 0.3. Oh, in fact, I'm using not the millimeters. Oh, yes, I am using millimeters, so it should be 9. And this, and also I need to change the density to tons per millimeter cube. So let me just quickly do that. Oops, I can't actually. So kg per meter cube to tons per millimeter cube. So I'm not sure whether this is, yeah. So 7,200 converted, so it should be this. Oh, not this one. I need the metric ton. Probably this one. Yes. 7,000. Yeah, it should be 7.8 into the power 9. Alright. So this should be our mass density, elasticity, and sorry, 9 and plasticity. So it's 2 50 megapascal with 0 plastic strain, and then I have the yield stress of 3 is around 380 megapascal. Yep. So this is 80, 2.9 and 0.17 is a plastic strain. Alright, so now I have the bolts, which are the high strength bolts. So these are, what did I do? Okay, my bad. I need to copy that. Oops. Yeah, I just renamed my previous thing. Yes, I can just rename this, let's say, as my steel, and the other is just the bolt. So the bolt that I have is a high strength bolt, so more or less everything is the same, but only its capacity, overall capacity, because it's a high strength, so its modulus is higher and its yield stress is higher. And not sure, but it should be something 100 to 6, and the plastic strain is, let's say, 0.4. Okay, so the next thing we're gonna do is to assign the section to each and every pod. Section assignment. First one is the angle. Let's just create also the sets as well. Yeah, so probably not for the angle. Everything that is more than one will not create set now. Probably we will create set later, but anyways, so I don't want to create any sets now, so I can just check this bar, select the region to this, and this is the region, then done. So I do not have any section. I can define sections. So the section 1 is the steel section, because we will use this section for all other steel components rather than bolt. It's a solid homogeneous section, and the material is the steel. And okay, so now the section is assigned. Once the section is assigned, you will find that the color is changed, which turn into green. Now the base plate, same section assignment, don't need sets, done. And the steel section is it, right? And there you go. Now it comes to bolts, so should be a different section. I'm gonna make sure everything is selected here, not the steel section. It will be the bolt section, and the only difference will be the material. The material will now be the bolt. Okay, so again choose bolt section here and done. And then the lower part, section assignments, steel section, done. And the lower part, I don't need to assign any section to this, but anyways, if you want, because I'm not using this anymore, the only purpose of this was for the weld, to extract the weld connection. But anyways, you can always assign section to this, doesn't matter really. Even you can entirely delete this. Again, the upper plate, done. Steel section, done. And finally, so now even I can assign a different material property to my weld as well, but anyways, I'll use the same material properties as my steel. So the steel section, or even can use the bolt section, whatever is your preference, or even you can define a separate material properties to your weld. Okay, so now we are done with our property module. The model is already assembled, and so in the next video we're gonna go through the step module, define our loading history, meshing, constraints. We'll try to wrap all those in just a single video. Alright, so that's it for this video. See you in the next video.